All right, hello everyone. Welcome to today's Better Buildings Alliance Renewables Integration Technical Team call on identifying cost-effective energy efficiency and load flexibility measures supporting grid interactive efficient buildings. I'm Rose Legner from NREL, and I will be kicking off the call today. Next slide. For those new to these calls, the Renewables Integration Team has a focus on the strategic use and integration of renewable energy sources with commercial buildings, building load flexibility, electrification, carbon reduction, and grid coordination. We provide a wealth of resources, information, and guidance materials on these topics to building owners, managers, and other relevant stakeholders. And our resources can be found on our team website, which we have a link to on this slide. Next slide. Our agenda today will include some quick announcements from my colleague, Tim LeClaire, a technical presentation from Sheldon Madonsa from the Rocky Mountain Institute, RMI, and Christina McPike from WinnCompanies. This presentation will cover RMI's latest study on the cost effectiveness of grid interactive efficient buildings, or GEBS is the acronym. The study is specifically focused on multifamily buildings and is the third study of a three-part series looking at the potential of GEB strategies in various building portfolios. So in the past, these presentations have been really well received, and I'm really excited for this team to present on the findings of this particular study on multifamily buildings. And then we're going to end the call with discussion and Q&A led by Zara Falahi. And during this time, please use the Q&A, or throughout the call, please use the Q&A chat function to enter your questions, and we will try to get to as many as we can at the end of the call. Also note that this call is being recorded and will be archived on the Better Buildings Solutions Center. We'll send a link to this after the call to all the participants. And before we move to our quick announcements and technical presentations, I'd like to introduce our Renewables Integration Team because we've had some changes. So let's move to the next slide. First, I've had the honor to lead this team, and it's exciting work over the past 4 years. And the time has come for me to transition to other projects. So with this transition, I'm handing the leadership of this team to Tim LeClaire. Tim is a senior researcher with over 25 years experience developing and deploying advanced energy efficiency technologies. He currently works in the Building Thermal Energy Science Group at NREL and was previously at the Oak Ridge National Laboratory. His research interests include energy storage and utilization, heat transfer, thermal fluid sciences, boiling and two-phase flow, electrification, decarbonization of buildings, as well as vehicle fuel efficiency and electric vehicles. His recent research at NREL has focused on R&D of phase change thermochemical and sensible thermal energy storage systems in support of the Department of Energy's Store for Build consortium for building energy storage. So welcome, Tim. We're really excited for your leadership on this team, and I will ultimately hand it off to him today. Also on the team is Zara Falahi. Zara has been a technical lead on this team for the past 2 years. She's been very engaged on our research projects and with our GEB working group that we hold, and she actually is managing the discussions that we have with that group. Ali Georgeson is also a new member of the team. Ali has worked extensively with Better Buildings in the past and has joined our team as our new stakeholder engagement manager. So you'll be hearing from her and receiving emails from her moving forward. And Kim Trenbath has joined the team for the past couple months to help transition the team and provide strategic guidance. She's a senior research engineer at NREL and also has many years experience working with Better Buildings. So welcome to the new members of this team, and I'm going to officially hand the baton off to Tim at this point, and we'll jump into the next part of this call, or the presentations, etc.
Great. Well, thank you so much, Rose, for the kind introduction. I wanted to just thank you for your years of service and contributions to this team on behalf of the REI team. We'll definitely miss you moving forward, but excited to take on the lead of the REI team. So next slide. Well, moving into announcements, I'll just go through kind of quickly several announcements that we have. So next slide. First, we want to remind everyone that we have a Grid Interactive Efficient Buildings site at DOE. This includes technical reports, key BTO project summaries related to Geb's work. So if you're not familiar with that, check that out. A lot of great resources there. Next slide. Just a reminder that all of our webinars and team calls are recorded. So if you miss something, if you look through the list here, see anything that's of interest, feel free to go check that out and listen to it at your leisure. This call will be recorded as well, should be available within a few days. Next slide. Our previous call was back in March, addressing selecting and connecting EV chargers to commercial buildings. So if you missed that one, definitely go and look. That was a very popular one, had a lot of attendees and a lot of great information there. Next slide. Just real quickly, a few notable publications. This webinar today will cover a report that was just published from RMI for cost-effective grid interactive efficient buildings, the potential for the WinnCompanies portfolio. So that has a lot more information than what will be covered in the webinar. If you're interested in more details, please look at that report. Next slide. There were actually, this is the third in a series of studies from RMI. There were two others. There was one on the GSA portfolio, and also this report that's shown here for GEB efficiency in a US retail portfolio. So another great one, just looking at other applications. Next slide. And upcoming presentations, publications, excuse me, we will be publishing some EV case studies for commercial real estate and K-12 schools. And then also there's a FERC 2222 fact sheet that will be published here shortly. So watch for those on the website. Next slide. So with that, we'll move into our technical presentations. Just wanted to introduce quickly. Next slide. Leading the presentation is Sheldon Mondanza. Sheldon is a manager with RMI's carbon-free buildings practice, where he's working with a team to build an in-house analytical tool called Portfolio Energy Optimization that evaluates large portfolios of buildings for deep energy retrofits across North America while optimizing around investment thresholds, carbon emissions, utility rates, weather zones, and end use cases. Sheldon received his BS in mechanical engineering from the Monopole Institute of Technology and his master's in energy management and systems technology from the New York Institute of Technology. Christina McPike is here with us. She is the Director of Energy and Sustainability at WinnCompanies, which is a 50-year-old multifamily housing owner, developer, and manager. Since joining Winn's Energy and Sustainability team in 2013, Christina has implemented over $50 million worth of energy efficiency upgrades across Winn's portfolio. So under Christina's leadership, the Winn development successfully integrates high performance and low carbon design in every project, from occupied moderate renovations to ground up new construction and deep energy retrofits. So With that, I will turn it over to Sheldon and Christina for the presentation. Thank you.
Thank you. Tim, can we go to the next slide?
Yeah, thanks, Sheldon. Thanks, Tim. As Tim said, I'm Christina McPike. I'm the Director of Energy and Sustainability. I work at WinnCompanies. We're an affordable and mixed income multifamily housing owner, developer, and property manager based in Boston with a portfolio of about 12,000 apartments, or about 100 properties, give or take, across the Mid-Atlantic and Northeast regions. We are also a Better Buildings Challenge partner. Sheldon is going to do the bulk of the presentation today, but I am honored to participate and offer sort of an owner's perspective here at the start and again later on in the presentation and during Q&A. But as the slide shows, and as Tim's introduction alluded to, and maybe my participation here suggests, Winn is kind of unique. We've had an in-house sustainability department for 15 plus years now. Sustainability is part of our normal business plan as an operator of buildings and, more relevantly, communities where people live. So we consider energy efficiency, water conservation, and renewable energy, and we have for some time now. As a result, and I think one of the sort of lesser surprising findings in the report that Sheldon will be presenting, that in some ways kind of hurts us from an economic perspective and carbon, is that our portfolio in many ways is already performing pretty well. And that's what this graphic over here on the side of the slide shows. We have an average EUI of about 59 kBtu per square foot, which is 60% better than the regional average for multifamily buildings in the Northeast United States. Obviously, again, as the graphic shows, there's a few outlier properties there, and this portfolio represents just a subset of our total portfolio. We excluded certain building typologies, which Sheldon will get into later in the presentation. But because of this, you know, the existing baseline energy profiles of our properties, of our communities, certainly had an impact in evaluating the impact that GEBS measures can have on the portfolio in terms of economic returns and carbon emission savings. So with that sort of introduction to WinnCompanies and our portfolio of multifamily housing, I'm going to hand the mic back over to Sheldon, and thank you all for joining us.
Thank you, Christina, and thank you, everyone. I'd like to welcome you to the presentation. I'll be going through a number of different slides and a lot of content, so I'll try and be brief so we have enough time for a Q&A. Please use Google Doc to log your questions if you have any during the presentation. Next slide. During my presentation, I'll be breaking up into three main parts. We'll go over the overview of the portfolio. We'll then dive into key findings at the portfolio level, and we'll take a deep dive on demand profiles and how GEBS measures actually impact demand profiles on a building basis. Next slide, please. The purpose of the study. So there were three main goals of the study. The first and foremost goal was to actually evaluate GEBS measures on a real-world multifamily portfolio. The supporting sort of goals were to inform emerging national conversation around demand flexibility and to evaluate how load flexibility, efficiency, renewables, and energy storage measures can work to reduce peak demand and consumption, but also impact CO2 emissions. We are hopeful that the findings of this report can be applied to the multifamily sector as a whole, and some of these findings can encourage other multifamily owners to adopt GEBS more broadly. Next slide. There are essentially three main building blocks of a GEBS building. And for people that have joined past presentations on GEBS, you'll know this. We define GEBS buildings as an efficient building that can flex demand and reduce demand, as well as that buildings that have on-site renewables and storage. So these main three building blocks actually combine to form a high-performing GEBS building. You apply electrification to these building blocks and you get a decarbonized along with carbon-free electricity grid. Our study focuses on the three main building blocks. That's efficiency, demand flexibility, and on-site renewables and storage. We did apply heat pump measures as an add-on to look at the impact of GEBs on heat pump and electrification as well. Next slide, please. This provides an overview of the analysis. We, as Christina mentioned, we selected 29 properties to evaluate. They were spread across 6 states and 3 climate zones. We selected these 29 properties because they were medium to high-rise properties. We left out all the row houses and 1 to 3 floor properties that WinnCo operates and manages. These properties range from size between 45,000 square feet to close to 1 million, that's 900,000 square feet. Our tool that's now called Zetro, previously known as Portfolio Energy Optimization, modeled each of these buildings. We modeled, we generated Energy Plus models from the bottom up. We've modeled over 5.3 million square feet for this project, applied 90 plus efficiency measures, GEBS measures, and we'll get into what these measures were. And eventually, by the end of the analysis, we covered about 1,500 simulations to come up with our findings. The buildings have a mix of, master metered buildings, of about 13 master metered buildings, 16 direct metered buildings. A lot of the buildings were under Section 8, and a majority of the buildings are under Section 42 or low-income housing tax credit. We've had to build measures, or we've had to build utility rates from the ground up for each of these buildings. So the tenant and the owner meters and utility rates were built based on actual bills. Next slide. Now, there were a number of different conditions, existing conditions that we had to take care of when we were modeling these buildings. The diversity of these conditions within the portfolio impact performance, but they also impact our recommendations. There were about 10 plus central and decentralized HVAC systems that we modeled. On the right-hand side, you can see the graph where EUI is on the y-axis and the size of the buildings on the x-axis. We can clearly see that buildings with heat pump and energy recovery ventilations were the highest performing buildings, with an average EUI of about 42 kBTU per square foot per year. What was counterintuitive is we found that condensing boilers with central cooling plants had a higher EUI compared to condensing boilers without central cooling plants. And this is counterintuitive because actually central cooling plants are more efficient than through the wall or window AC units. But we believe this is because of occupancy and tenant end use. And generally, we also think that central plants serve a lot more of the building, like common areas, throughout the year. Next slide, please. So this slide provides an overview of our modeling approach. We use a software-based consulting model. Like I've said, RMI has built a Zetro over the past few years and applied this platform to a number of different portfolios. We divide the analysis in three main stages. One is data collection, energy models, and then the financial analysis. During data collection, we work with the clients and we meet the clients where they are. So we collect data that's readily available by the clients. So things like drawings, we access Portfolio Manager, Energy Star accounts. We use bills to look at their historic energy use, but we also use publicly available data. So we use things like satellite imagery to build geometries for each of the models. We also use publicly available data on utility rates and emissions to collect a data set. Once we have a good data set of the 29 properties that we evaluated, we then transfer that to a simulation engine. Our simulation engine contains over 200 templates that uses this data, this baseline data, and automatically generates baseline models. We then calibrate these models to historic energy use, where we had historic energy use. And then essentially what we have is a digital twin of the portfolio. During this process, we also work with the client and we work with NREL to focus on economic thresholds. where the measures that we actually applied need to meet those economic thresholds. We also looked at certain carbon reduction goals during this analysis, and we used them as guardrails to apply individual measures. Once we have individual measures applied to the building, we then bundle them to come up with building-specific investment plans. These building-specific investment plans are then bundled to the portfolio level, and we look at what impact that has on the entire portfolio utility costs as well as investment potential. During this process, we, like I've said before, we went through about 1,500 energy models to come up with our findings. Next slide, please. So we'll get into some key findings here at the portfolio level, and then we'll drill a little bit deeper into measures and buildings. Next slide, please. Here we've analyzed about 13 measures, and by measures, I mean measure categories that cover 4 broad areas. That's renewables, renewables, demand flexibility, envelope efficiency, HVAC and plug load efficiency, and heat pumps. Now, each of these measures could have multiple variations. So overall, we had about 90 plus energy and financial combinations that we went through and applied to each building. Each building gets a subset of these the energy, or ECMs, we call them, energy conservation measures or GEBS measures, because existing conditions really matter when we apply measures. So I'll give you a couple of examples. Battery storage had 3 different variations where the battery was sized to target 10%, 30%, or 50% peak load reduction for a particular building. We had a number of insulation measures that went on into these models. For example, we had insulation that were R20, R30, and R40. Each of these were applied to every building in the portfolio. We also had several measures for roof insulation. And so combined, all of these variations were about 90 plus. And our findings will show that a number of these measures panned out financially, as well as saves carbon emissions along the way. Next slide, please. So this provides an overview of our findings at the portfolio level. There were 2 main scenarios that we defined. They were based on financial thresholds. So on the right-hand side, you'd see a graph where on the y-axis, we have NPV potential. On the x-axis, we have payback in years, and this payback varies from building to building. This payback is essentially at the portfolio level. This is a portfolio level snapshot. The 2 main scenarios were a 10-year payback. So every measure package that we applied to a building needed to meet that 10-year payback threshold. If it met that 10-year payback threshold, then it gets added to a building. And the other financial metrics was a 6% IRR scenario, which essentially meant that every single bundle that we applied to a building needed to meet a 6% internal rate of return. And if it did meet that internal rate of return, it goes into the portfolio, or if it does not meet that internal rate of return threshold, those measure packages get filtered out. We can clearly see that there's a potential to save 800 kilowatts of annual peak demand across 21 buildings. So we found that 21 buildings out of the 29 have measures that meet this financial, either the 10-year payback or the 6% IRR financial threshold. For these 21 buildings, there's a potential to save about 800 kilowatts of annual peak demand. With a 6% internal rate of return, the portfolio could save about $700,000 annually on utility costs, that's gas and electricity included, and also cut carbon emissions by about 1,600 tons. Rooftop PV was the single largest potential for both NPV as well as carbon emissions, and was financially successful on 13 out of the 29 properties. That's followed by HVAC and plug load efficiencies. They had the second largest carbon emission reduction and NPV potential. I should note here that during the financial analysis, we apply an incremental cost. So we do not recommend taking out or replacing any equipment that is not at the end of life, end of its useful life. So we use an incremental cost basis for our project costs. Next slide, please. So broader insights from the multifamily sector. As Christina mentioned, WinnCompanies is a high performer in this space. Combining WinnCompanies' existing strategies along with the findings of this report, we believe that there are 4 main areas that multifamily portfolio owners or building owners should look into, and that is, rooftop solar has panned out in close to 50% of the buildings within the portfolio, and I think that that's a high potential area for both carbon savings as well as electricity and demand savings. Most of the buildings in the portfolio we analyzed already had LED lights, so we recommend LEDs with integrated sensors, so they can be dimmed during high peak demand periods. We also recommend replacing older common area washers and dryers with high efficiency models, and implementing smart thermostats for master metered buildings that have central cooling and heating plants. We've seen that this has panned out financially pretty well across the portfolio. Next slide, please. The 6% IRR scenario. This is a deeper dive on the actual numbers for this scenario. Our modeling has shown that with an investment of about $3.9 million, there is an NPV potential of about $4.5 million. And overall, for this scenario, we see a simple payback of 5.5 years. Like I've said before, the payback varies by building. Some buildings, on the lower side, it was 1.1, 1.5 years. On the higher side, it was 8 or 9 years. The portfolio can save about $700,000 per year on utility costs. That's about a 10% reduction, purely based on GEBS measures, a total of 800 kilowatts in savings, and 1,600 tons of CO2 savings. That's about 7% reduction in CO2 over the portfolio. The most successful measures, like I've said before, is solar PV, wall insulation, LED fixtures, and replacing washers and dryers with high efficiency models. I should note that this was not a decarbonization study, so our focus was on maximizing GEBS measures. So that's efficiency, demand flexibility, and on-site renewables and storage. If it were focused on decarbonization, our bundling methodology would have been different, and we would have focused more on the CO2 savings and sort of optimize around that first, and then optimize around financial thresholds. We did the opposite here for the purpose of this study, based on the scope of this analysis. We focused on cost-effective GEBS strategies and then applied heat pumps or electrification measures to these buildings. Next slide, please. This is an interesting view of the analysis where we actually produce building by building actionable ESAM packages. And here, what you see here is that certain buildings have a much higher NPV potential compared to certain other buildings. And this enables the portfolio owner, this view enables the portfolio owner to pick high potential sites for pilot projects. And we've done several projects like this, and some of the larger projects we've actually identified that the highest potential building has 70 times the potential compared to the lowest potential building, NPV potential only. And this also helps building owners to plan for CapEx and to deploy capital in an optimal way. So there are always constraints on budget. So by picking the highest potential buildings and implementing these measures, GEBS measures in those buildings, enable the portfolio to learn as they implement projects. Here we see there are 4 main categories that we've divided this into: HVAC and plug load efficiency, renewables, envelope efficiency, and demand flexibility. From this, we can also say that these buildings have a certain potential, but also which area to focus on for these GEBS measures. Next slide, please. This is the second scenario, 10-year payback scenario. The financial threshold was a bit higher. So you can see that although this investment potential is about 2.8 million, it's lower than the 6% IRR scenario. You have an NPV potential of about 2 million, and the payback at the portfolio level reduces by a year. So there's a simple payback of about 4.3 years. annual energy electricity savings of about 642,000 per year. This potential for about 600 kilowatt of annual peak demand reduction and 1,500 tons of carbon reduction. Some of the most successful measures were similar to the 6% IRR scenario, where we have solar rooftop demand flexibility that panned out well here, and replacing common area washer and dryers with high efficiency models. We also had two scenarios. In this scenario, we had two buildings with where a heat pump measure panned out, and this contributes to the carbon savings potential. Next slide, please. This is again a similar look at the 10-year payback scenario. We have a building by building look. We also identify which buildings are the highest potential buildings, which areas to invest in, and have identified buildings where potential sites for pilot projects. Similar themes here that we've covered before, so I won't get into too much detail. Next slide, please. Great. So we'll also take a look at some impacts on demand profiles, and the next few slides we'll do a deep dive on one building. This is a building one that's based in Connecticut, and we'll look at how different measure packages impact demand profiles on a monthly basis, and also how they impact demand profiles on an hourly basis on select days. And we'll get into why these measures impact these profiles in a certain way. Next slide. So here, like I said, this is building one in Connecticut, climate zone 5A. There are about 4 graphs here, 4 demand profiles here to the left. So we have the dotted line, that's the baseline demand profile. The blue line is actually the 6% IRR scenario that actually panned out financially and was part of this portfolio analysis. We also applied 2 additional measure packages where the heat pump scenario and the heat pump plus scenario. In the heat pump scenario, that's a light green graph, we only electrified heating and domestic hot water. We did not apply any other measures there. And you can clearly see the impact of electrification during the winter months. In the heat pump plus scenario, we applied GEBS measures as a whole. So we've applied rooftop solar, we increased roof and wall installation, high efficiency plug load measures, we improved window performance, and we also added a battery measure. And you can clearly see the impact of this GEBS package on the demand profile of an electrified building. So as such, you have to compare the baseline with the solid blue line and the 2 heat pump measures together. We can see that during the winter months, because of electrification, the heat pump plus and the heat pump measures have high loads, high winter loads, and they kind of drive the demand profiles in the winter. For the heat pump measure, we see that the winter demand profile is much higher than the summer loads. But this is not the case for the heat pump plus scenario. In the heat pump plus scenario, we see that winter loads, although are higher than baseline, but they're not much higher than the peak loads for the building. And so to electrify buildings, we can clearly see that GEBS measures play a critical role to manage peak demand costs as well as peak demand on the utility side. In the baseline versus the 6% IRR scenario, we can see that the measures like rooftop solar PV, common area washers and dryers, and light dimming reduce the loads during the winter months. And I'll make another note here. This is a northeast climate zone, and so a lot of the cooling loads are driven by high humidity conditions during the summer months. Next slide, please. Here we are looking at, we'll take a look at a mild day, that's April 6th. We can clearly see that the heat pump plus scenario shows a drop of about 24% when compared to a heat pump scenario. And the 6% IRR scenario shows a 26% decrease. from the baseline peak load. The two scenarios have solar PV arrays show a much lower midday load. That's from about 9 a.m. to about 3 p.m. You can clearly see the impact of solar on this. We've also, if you remember, we've applied a number of different measures that is, the battery measures and, envelope efficiency measures that reduce load in the heat pump plus scenario. Next slide, please. This is a peak winter day, so it's Feb 2nd. We can clearly see again, when compared to the baseline, the 6% IRR scenario is lower during the day due to the solar. We can also see a lower peak during the evening periods as people come back from work. When we compare the heat pump plus scenario and the heat pump scenario, we can also see that throughout the day, the heat pump plus scenarios, the Gibbs measures are working really well. And we can see, the heat pump plus scenario has a 31% lower peak demand when compared to the heat pump. Because we have electrified loads, like we've electrified heating as well as DHW loads, the heat pump and heat pump plus scenarios are obviously much higher than the baseline demand. Next slide, please. Here we have a peak summer day, August 18. Again, the 4 different scenarios, the two load profiles that we should look at together are the dotted line, the baseline, and the 6% IRR scenario. There's not much of a difference here because, like I've said, the efficiency measures are have an impact, but during the peak load conditions, it's mostly driven by latent loads or humidity, and that efficiency and Gibbs measures don't have much of an impact on high humidity. We see that the heat pump plus and the heat pump scenarios are not much higher than the baseline during this day, even though we've added domestic hot water loads, and that can be attributed to increased efficiency of the heat pumps during heating and cooling events. Next slide, please. Perfect. I've gone through most of the slides. I hope that we will have a more fruitful Q&A session. I'll hand it over back to Christina.
Thanks, Sheldon. It's amazing to see in maybe less than 30 minutes the many months of work that went into all of that, not to mention the more than 1,500 energy models and simulations considered. So yes, I think we will have a good Q&A to follow. This slide and what I'm going to end with is really kind of a look ahead. We were are very excited to have participated in this study with RMI. At the time, we had never heard of GEBS, the acronym. Today it's certainly more commonly used, but it's still a new and growing concept, particularly in multifamily housing. And that's been our experience, despite a lot of really good work and progress over the years around energy efficiency and installing solar panels. Historically, when I would pick up the phone and try to find a battery storage developer, for example, interested in designing and developing a battery for one of our multifamily properties, because we have relatively smaller demand profiles than, say, the Empire State Building, we're not a typical candidate for things like demand response, but even demand charge management and the flexible strategies and load flexibility that Sheldon was talking about and presenting about. And I think the Department of Energy has recognized that. And I guess the only thing I'll add there is, despite multifamily housing not having the, call it, ideal, maybe commercial demand profile, we are housing residents that would benefit the most from the resiliency benefits ancillary benefits of technologies like battery storage, not to mention deep energy retrofits and electrification and the health benefits of doing those types of investments. So, during and sort of now as we wrapped up this study with RMI, we're really excited to sort of announce now or share now that we have received a grant from the Department of Energy's Connected Communities Initiative and have kicked that off earlier this spring. With this funding from the Department of Energy, we're working with Fraunhofer Institute and several vendors not listed below, and our own related entity, Open Market ESCO, to sort of take this study, this analysis to the next level. We're going to take 6 of our properties and do a much deeper dive, auditing, physically walking, inspecting, sub-metering specific loads, both at the utility meter level, but also equipment level, and developing very detailed load profiles and grid interactive efficient building solution packages and upgrades that will include many of those ECMs that Sheldon presented on, and deploy hopefully definitely one and hopefully 2 GEB pilot projects at 1 or 2 of the multifamily properties that RMI evaluated as part of this project. So while we're just kicking off, really sort of new to the cooperative agreement with the Department of Energy, this is where we're focusing much of our time, attention, and resources to over the next 4-year performance period with the Department of Energy, after which we're very optimistic and hopeful that we'll be able to not only continue to decarbonize our portfolio, but demonstrate commercially viable business, plans to deploy battery storage, EV charging, and other GEB solution packages to the affordable multifamily housing space. So with that, I think next slide, and we're going to transition into Q&A. Thank you all.
Sorry, you're on mute. Thanks for letting me know. I wanted to thank our presenters for the great presentation and also our audience for providing great questions here. The theme of the questions are on the analysis as well as the implementation of the measures on the WinnCompanies side. I start with a few analysis questions, Sheldon. There are some questions about the potential savings. For example, the 6% IRR scenario had a 702K savings. Is it just on energy savings, or does it include demand charges and time of use rates?
Great question. So we built specific utility rates for both the owner and the tenant side, and we included, we basically built ground up utility rates that included time of use, demand charges, kilowatt hour charges, and they were different for master metered buildings and direct metered buildings. So every single building got their specific utility rates that they're paying currently.
Great. And I guess I want to move from rates to carbon calculations. Did you associate any value with carbon reductions?
We did not. And, this was more around cost-effective GEBS measures. And so we didn't really focus on carbon in this study. And for the Northeast, there's not direct application or direct financial benefit of saving carbon dioxide. However, there are some policies, and Christina will be able to talk a little bit more about policies that focus on buildings reducing carbon emissions, both in New York City and in Boston, and there are associated fines with it. We did not include that in the analysis, but if we do, our recommendations would have changed.
Great. Christina, do you have anything to add to that in terms of the policies?
No, I think Sheldon covered it pretty well.
Great. I guess, Christina, I have this question for you of if WinnCompany is considering any net zero energy design or net zero energy building in their portfolios?
We are considering it, yes. We do ground up new construction projects across the Northeast, where I think that's the most relevant, not immediately related to a GEB measure. but we are building passive house certified multifamily housing and evaluating how much further from passive house do we need to go to achieve net zero. We could cover every inch of available roof area in a multifamily passive house certified property and still consume much more energy from the grid than we would be able to produce. So in those cases, we're exploring in one particular property in Washington, D.C., basically enrolling all of our residents in community solar and executing green power options for buying clean energy. The first sort of focused on efficiency and then maximizing renewables on site before going off site.
Great, that's fantastic. I hope we have like a future webinar learning more about those efforts. I guess while we're talking about community solar and like providing distributed energy resources, how do you describe your working relation with utilities? What's the implementation process of, you want to do electrifications, you want to do solar, how do you work that out with utilities?
That's a great question. And the utilities have to be at the table. It takes many stakeholders, not only the building owner, you can have the best engineer and consultant in the world, but the utilities ultimately have to be at the table. So some of our deep energy retrofit projects, including one that is participating in RMI's Realize initiative, EVOI departments in Boston, for example, will be converting that building, which is gas heated, to electric, doing a comprehensive building envelope retrofit to reduce loads, but we still have to bring in new capacity, new service from a very busy street, manhole 20 feet deep into the building. So that requires review and certainly cost. And so I think the utility companies need to be at the table as we electrify our buildings for sure. And then in terms of distributed generation, many utilities have very robust, streamlined programs in some cases, and others are take many years to navigate and have a backlog of applicants and require significant studies and high cost infrastructure and capacity upgrades before you can install solar. Battery storage is still new. I think we're really lucky in that most of our portfolio is in states like Massachusetts and Connecticut, as well as DC, with progressive, forward-looking states with good policies and good programs. That's not to say that there isn't still, a multi-year backlog in many parts of Massachusetts for building large community-scale solar, for example, all sort of pending capacity upgrade studies and figuring out who's going to pay for that. So that continues to be a challenge, but yes, the utilities need to be at the table and they are very important to getting these types of projects done.
Great, and thank you for mentioning other stakeholders that are at play. Sheldon, I have a question for you on the load profiles, daily load profiles. Can you elaborate more on how implementing these measures impacted the peak load? Was it the way you expected them to impact? And if so, how? And if not, what do you think caused it?
Yeah, that's a really interesting question. When we apply just a single measure, we can actually predict what happens with peak loads, right? Like when we apply, say, an efficiency measure, that the peak loads will reduce at a certain time because, for example, if you apply a roof or a wall insulation measure, throughout the year, you expect a peak load reduction. When you bundle these measures, unexpected things happen, right? And so what we've seen generally is that loads have been reduced, peak loads have been reduced. There is much lesser shifting of peak loads. So there's demand reduction, but less of demand flexibility and shifting it off peak. And I saw another question about that as well. There were some unexpected demand profiles, but every building is different. And if you look at those, the slide where we talked about the existing conditions, there were 10 different HVAC systems, and so each of these GEBS measures impact these HVAC systems differently.
And I'm assuming the unique characteristics of the portfolio you analyzed also impact the results. considering that, how do you think we can take the results and finding of these reports and scale them up to other portfolios in multifamily sector?
Well, we have a section in the report, and if you download it, you'll see that the focus of the report was around WinnCo's portfolio on the 29 properties, but we've also gleaned insights for the multifamily sector as a whole. For 29 properties, we saw about 800 kilowatts of potential peak reduction. You multiply that with a few thousand multifamily buildings across some of the large cities in the Northeast, you can really see the scale and impact of that, of GEPS measures. And we've done this, we've said before, we've done this for GSA's office buildings. And we're seeing some of the projects that have been implemented show very similar load profiles that we've projected. We've also done this for a retail portfolio and now a multifamily portfolio. And you combine these portfolios, you could clearly see the GEPS potential for citywide load reduction.
Great, thank you. Christina, I kind of want to ask your perspective on the business side of things. WinnCompany is the owner and operator. You rent out a lot of units. How does the GEP implementation happen when you have that like renter versus owner operator relationship?
Yeah, to be clear, we haven't actually implemented a GEBS project yet. But this is what we're going to be considering and evaluating and hopefully demonstrating through the Connected Communities grants. We have a mix, as Sheldon described, of master metered properties and individually metered properties. In almost all cases, in the case of battery storage and rooftop solar, these technologies are tied to the house meter. If it's master metered, there is only the one meter. If it's individually metered, we'd have a common area house meter that the building owner is responsible for paying, and which has the bulk of the load on it, especially when we have central plants like a central chiller and central pump station, as well as all the common area HVAC and flood loads and lighting and so forth. So those are the loads that we're really tapping into, and those are also the loads where the building owner can see the savings and therefore the sort of economic return or revenue associated with those kinds of investments. And that's really important. That's not to say that we don't want to, and in some cases may need to and are planning to share the savings and the benefits with the residents. There's an indirect benefit no matter what, right? If an affordable multifamily housing owner property saves money on utilities, most of these properties take that money and reinvest it in the property. So making capital improvements, offering community services and other programming benefits that directly support our residents. But we're also implementing in-unit upgrades. So the smart thermostats, for example, HVAC equipment upgrades in apartments that may be easier to modulate. Those are not only saving the residents on electricity costs that the owner isn't necessarily reaping or benefiting from, but we're saving the residents money, and that's a good thing. We're hopefully improving comfort, controllability of HVAC systems. It's also a good thing. So there's a balance there. But in terms of economics, and the reason why multifamily has historically been overlooked is because the load profiles are small. And so there's no scenario where you're really installing a battery and financing GEP packages by unit, by apartment. Instead, you're focusing on the larger central equipment, central loads within unit, apartment level loads sort of being ancillary or incremental add-on for hopefully less cost. There's many programs I'll add that are incentivizing smart thermostats and crediting directly on resident bills, a rebate, which is fantastic. And we're planning on signing up our residents for those things too.
Great, you kind of answered one of my next questions of how incentives would impact the implementation in the future. Sheldon, did you consider any incentives in analysis?
No, we didn't. When we were wrapping up the analysis, the IRA was just passed, so we didn't consider any Inflation Reduction Act incentives, nor did we consider local utility or state incentives. We did include solar tax rebates, so the tax credits for solar and for battery, but that was pre-IRA. But those are the only two measures where we included rebate, a tax rebate.
Great, thank you. I guess my next question is more on the heat pump modeling. Can you explain more on the details of how you modeled the heat pump? The temperature setbacks impact the heat pump operation?
So that's a great question. So we actually applied, we have several measures of the heat pumps. We have water source heat pumps run by an electric boiler. We have ground source heat pumps. We also applied, we looked at VRFs for multifamily buildings as well. And so, we looked at all of these three and ground source heat pumps as well, if I didn't mention that. We've looked at these measures, and then we do detailed energy modeling based on vendor cut sheets. So we actually go out and get vendor cut sheets and model these buildings based these technologies based on feedback from manufacturers. And so we try and get the part load efficiencies as well as full load efficiencies correct, which is really important when you're modeling, when you're doing energy modeling. Sorry, what was the second part of your question?
I think you provided enough detail for that question, but I kind of want to move forward to asking a bit more on basically heat pump performance and the high peaks that might be expected during winter, which could be severe on grid load and grid for peak load conditions than summer months. Do you have any comments on the wintertime and summertime comparison of the heat pump performance in the analysis that you performed?
Yes, so that's one of the really interesting parts of this analysis is that if you just apply heat pumps to existing buildings without taking into consideration other measures, it will impact the demand profile negatively, and winter peaks are higher than summer peaks. We can clearly see that in our modeling. But if you combine heat pumps with other efficiency, GEBs, and renewable measures, we clearly see that the winter peaks already, although are high, but they're not higher than the summer peaks. And so impacts on the grid or electrical distribution infrastructure within the building are minimized. And we've not only seen this in the multifamily analysis we've done, but we are also seeing it in the retail as well as the GSA office building report. And some anecdotal evidence from GSA that we've seen is that this actually, is panning out in terms of, applying heat pumps or applying electrification measures, but then applying it with efficiency, deep efficiency, and other GEBs measures, lower the risk of high peaks during winters.
Great, thank you. And we have only 3 minutes left, so I wanted to ask one last question of how do you think these recommendations vary with different climates? For example, if we move somewhere in Middle East, that it's cooling dominant.
So our analysis actually takes into account weather locations. And so if you look at the retail portfolio, we did 113 stores across all 7 climate zones, seven different climate zones covering 49 states. It so happened that the building profile that we were looking for, so the mid-rise and high-rise building profile, were mostly in the Northeast for WinnCompanies. And so the weather, location, humidity does impact GEBs, what GEBs measures pan out. It's really hard to have a direct correlation between a particular GEB measure and a location, or a particular GEB measure and a climate zone. And we've done extensive analysis on this. And what we found is that existing conditions, utility rates, HVAC systems actually have a bigger impact than location. Obviously, when we put all of this together, everything sort of interacts, and we have more of a scatter plot than direct correlations.
Great, thank you. And with that, I wanted to thank you and thank our presenters for this great technical presentation featuring the report. And I wanted to let the audience know all of the reports that we've touched on are available on the Renewable Integration Team's website. And if you have any questions, please keep in touch with us using this email. Thanks again for attending this webinar. I hope you have a great rest of your day.
Thank you.